Alright students, this is the second part of exercise 15.1. We have done up to 12th question. So let us take up 13th question now. 13th question, a die is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, an odd number. So let us just do it a little in a proper way, the way you can write in exam. Question number 13, we have been given a die is rolled or a die is thrown. So the first thing I want to write down is the sample space. So when a die is rolled, what are the possible outcomes? So I can get these possible numbers. Any of these numbers will appear. In the first part, I want the probability of getting a prime number. I hope you all know what a prime number is. A prime number is a number with exactly two factors. And those factors are 1 and the number itself. So out of these 6 numbers, how many are prime? 2 is prime, 3 is prime, 5 is prime. And we do not need the numbers, we need their counting. How many prime numbers do we have? There are 3 prime numbers. So there are 3 prime numbers out of 6. So the probability will be 3 by 6. You can give the simplified answer. I am leaving it as such. Second part, you need to find out what is the probability of getting a number lying between 2 and 6. So a number that lies between 2 and 6. Between 2 and 6 means 2 and 6 are not to be included. They will be excluded. So between 2 and 6. Between 2 and 6 we have these 3 numbers. So probability of getting a number between 2 and 6, it is also 3 by 6. Third part, probability of an odd number. How many odd numbers are there? So 1 is odd, 3 is odd, 5 is odd. Out of 6 we have got 3 odd numbers. So the probability in each part is 3 by 6. Next question, question number 14th. It's based on cards. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting. Now they have given you various options here. Before we do this, let us quickly revise what or how many types of cards does a deck contain. So usually when we look at playing cards, there are 54 playing cards, out of which 2 are joker. So whenever we are dealing with the cards, we only use 52 cards. That's why every time you will have a question based on playing cards, they will mention that the deck contains 52 cards and it is always well shuffled. So just revising, in a deck, a standard deck, it has 52 playing cards. You could easily look at the cards. If you have the cards at home, playing cards, look at the cards and try to study them yourself and note down the facts which I'm mentioning here. So out of these 52 cards, we can divide them into 2 groups based on their colors. So there are 52 cards, out of which 26 are red colored and 26 are black colored. So they are not completely red or completely black. The images on them have red and black ink used. So there are 26 cards on which the design contains red color, and 26 cards are such that the design on them is made up by black color. The cards which have red ink used have 2 particular designs. 13 have hearts on them and 13 have diamonds on them. The ones which are black are also having two different designs. 13 are clubs and 13 are spades, and these are referred to as suits. So how many suits the cards have? 4: hearts, diamonds, clubs and spades. The designs present, simply putting in layman's words. So the designs which are present on the cards, you will see hearts, you will see diamonds, you will see clubs, you will see spades. So there are 4 different designs on the cards, and these 4 designs are referred to as suits. Out of these 4 suits, 2 suits are in red color and the remaining 2 are in black color. In each of these suits there are 13 cards present, and those 13 cards are, we have ace, which is capital A, then we have king, then we have queen, then we have jack, and then we have the number cards from 2 to 10. So these are actually 9 cards. So we have 9 number cards. There are 3 face cards and 1 is ace. Face cards and ace together are called honor cards. I'll be writing that down later. You can note it down with yourself. So these 13 cards are present in each suit. So you will have ace, king, queen, jack in this suit along with 9 number cards. So 4 plus 9, 13 cards will be present with diamond design. Same 13 cards will be present with clubs design, and same will be present with the spades design. If you want, you can note down the hearts design. The diamonds is like this, a rhombus shape. A club is of this shape, tree sort of thing, and this is like a people tree leaf. So this is like this. So just to remember. So these 13 cards are present in all these designs. Remembering further, now I have mentioned what are number cards. The number cards are the cards from 2 to 10. So you need to know number of number cards. So we have 9 number cards of hearts. So 9 number cards are present here, 9 number cards present here, 9 here and 9 here. So these 9 cards will be present in all 4 suits. So there will be 36 number cards. Then we need to know face cards. Face cards which have pictures on them. So these are the 3 cards which have pictures on them: king, queen and jack. So 3 face cards with hearts design, 3 face cards with the diamonds design, these 3 with the clubs and these 3 with the spades. So 3 3 3 3 4 times. So how many face cards do we have? We have 12 face cards, and these include king, queen and jack. The number cards include 2 to 10. After this we have honor cards. Honor cards are ace, king, queen and jack. These are the highest scoring cards. So 4 here, 4 here, 4 here, 4 here. So these 4 are present in all these suits. So 4 times 4 will be 16. So there will be 16 honor cards. Remember this so that we can use this in probability. Now the questions could be mixed up. They could ask you how many kings, how many red kings are there. So if you look at the red kings, the one with hearts is also in red, the one with diamonds will also be in red. And overall there are 4 cards of each value. Ace appears 4 times in the deck, king appears 4 times in the deck, queen also appears 4 times, jack also appears 4 times, and the number cards also appear 4 times, one for each suit. So if there are 4 kings and we are looking for a red king, so out of the 4 kings, 2 will be red, 2 will be black. So if you want to write down the probability of a red king, that will be 2 out of a total of 52 cards. So just try to go over the deck of playing cards yourself. If you deal with them personally, you try to go over them and take a look and then look at these facts. It'll be easier for you to understand what I'm trying to explain here. Now based on this, let's do the next question, question number 14th. Now in question number 14th, they said there is a well shuffled deck of 52 cards. Find the probability that the king of red color is obtained. So this is what I was mentioning. Out of 52 cards, how many kings are there? So out of 52 cards, there are 4 kings, and out of those 4 kings, 2 are red and 2 are black. If you want, you can write down there are total 52 cards. Then kings are 4, out of which 2 are red and 2 are black. So this is what we have. We want probability of red king. So how many red kings are there? 2 out of 52. Second part, we want to know the probability of a face card. So probability of face card, we've already written here how many face cards we have. We have a total of 12 face cards. So 12 face cards are there. The probability will be 12 out of total 52. The total remains same. The total is 52 unless a card is removed. Sometimes in the question they will say that a few cards have been removed. In that case, the total number of cards will reduce. Be careful in that case. Third part, probability of red face card. Probability of red face card. Now this is a simple fact. The deck contains 52 cards. Half are red, half are black, and it applies to all the cards. If you pick any cards, half will be red, half will be black. So face cards are 12. So face cards are 12. Out of these, half will be red and half will be black. So 6 red, 6 black. Keeping this in mind, write the probability. So 6 red face cards out of a total of 52 playing cards. Let's do the next one. Probability of jack of hearts. Probability of jack of hearts. So in the hearts suit, how many jack are there? Let's go back to the list. So this is the list which shows the cards of hearts. In the hearts suit, there is just 1 jack. So the answer for this part, the probability of getting jack of hearts is 1. 1 out of 52. Fifth part, probability of a spade. So out of total 52 cards, how many spades are there? So spades are here, I've written 13 spades. So 13 by 52. Sixth part, What is the probability of getting queen of diamonds? Queen of diamonds. So in the diamonds suit, in this suit, if we list all the cards and we want to know how many queens are there in this pack, sorry, in this suit, how many queens are there? There'll be just one queen. There are total 4 queens and one is present in each of the suits. One in hearts, one in diamonds, one in clubs and one in spades. So if you want to know how many queens of diamonds are there, there will be just one out of total 52 cards. Question number 15th is also based on same concept, the cards thing. Let's take a look. Question number 15th, 5 cards, the 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. Now they are not taking the complete deck, they are only taking these 5 cards and these 5 are of diamonds. So we don't have hearts, spades or clubs. 5 cards and the design is diamonds, the suit is diamonds. They are well shuffled and they are put down, means they are facing downwards. You cannot tell which card is placed where. One card is picked up at random. First part, what is the probability that the card is a queen? So there are 5 cards out of which one is a queen. The probability for this will be 1 by 5. Then if the queen is drawn and put aside, drawn here means taken out. So in this case, in the first part, when the card was taken out, assume that it's a queen and then that card is just put aside, it is not placed back. So how many cards are we left with? We will be left with 4 cards now. Now out of those 4 cards, another card is picked up. What is the probability that it is an ace? So if we delete the queen from the list, we have 4 cards. Out of those 4, how many aces do we have? We have just 1 ace. So the probability of getting ace will be 1 by 4. And then from these 4 cards, what is the probability of getting a queen? Now there is no queen left, so the probability will be 0. If you want, you can write that down. So there were 4 cards, 10, jack, queen, king and ace. 5 cards. Then probability of getting queen is just 1. There is 1 card out of 5 which is a queen. And then in the second part, what happened? The queen is removed. We are left with 10, jack, king and ace. Now we have only 4 cards left. So queen is removed. Now write the probability of getting an ace. So out of 4, how many aces do we have? We have 1 ace. And what is the probability of queen now? There is no queen here, so this will be 0. Okay, now let's take up question number 16th. This one is a simple question, question number 16th. "12 defective pens are accidentally mixed with 132 good ones." So if 12 defective pens are mixed with 132 good ones, what is the total number of pens? That will be 144. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So good pen. How many good pens are there? 132, and the total number of pens is 144. So this you can write down yourself. 132 by total 144. Or you could make a statement and then give your answer. Question number 16th. We have defective pens 12, good pens it's 132, then total it is 144. Then the probability of getting a good pen will be 132 over 144. Question number 17th. Question number 17th is like question number 15th. So they are saying there is a lot of 20 bulbs which contains 4 defective bulbs. Total bulbs are 20, 4 are defective. So how many are good ones? 16 are good ones. One bulb is drawn at random from the lot. What is the probability that the bulb is defective? So out of total 20 bulbs, 4 are defective. The probability will be 4 by 20. Further, suppose the bulb drawn in first part. So in first case, they were saying that the bulb is taken out from that lot. So if the bulb which we took out in first part is not defective, it was a good bulb and it is not replaced. Now one bulb is drawn at random from the rest. So the bulb we took out in the first part is not defective, means it was a good bulb, and it is not replaced. Not replaced means it was not put back in the lot. It was taken out and kept out of the lot. So suppose the bulbs are in a box. There are 20 bulbs in the box, out of which 4 are defective ones. Means 16 are working, 16 are good. We took out one bulb. The probability that the bulb is defective will be 4 by 20. And then the bulb that was taken out in the second part, they are saying that the bulb is not defective. Means the bulb was good and it is not replaced. It is not put back in the box. So the box has now one bulb less. Earlier there were 20 bulbs in the second part. Now there is one bulb less. There are 19 bulbs. And the one which has been removed is a good bulb. Earlier there were 16 good bulbs. Once that good bulb is removed, there are 15 good bulbs left. What is the probability that the bulb taken out the second time is defective? So that will be, the bulb is not defective, means the bulb is good. That will be 15 over 19. Let's write it down, that will make more sense of it. So in the first case, there are total 20 bulbs, out of which defective are 4. So the good bulbs are, let's subtract, 16 good bulbs are there. So the probability of getting a defective bulb in the first part, the probability of getting a defective bulb, this will be 4 over 20. Then in the second part, the bulb taken out in part 1 is not defective, that is, it is a good bulb and it is not replaced, means it is not kept back. It has not been put back in the lot. It is now out of the lot, separated from the lot. Therefore, total bulbs will now be 19, one less. Defective bulbs are still 4 because the bulb which is removed is a good bulb. And the good bulbs are now 15. So in the second part, we need to find out that the bulb is not defective. Not defective means a good bulb. So good bulbs are 15 out of a total of 19 bulbs. So this is what the probability will be for question number 17th. Now let's take a look at question number 18th. A box contains 90 discs which are numbered from 1 to 90. One disc is drawn at random from the box. Find the probability that it bears means the number which is marked on it, two-digit number, a perfect square, a number divisible by 5. You have done these type of questions. Now before we write down the probability, we want to know how many discs are there. The discs are numbered from 1 to 90. This could also be a random number. So what if it was 11 to 36? Think about that situation as well. You will have such questions in the assignment. Question number 18th. We have been given that there are total 90 discs. Numbers are 1 to 90. So this is important. The counting marked on the discs, because based on this we shall be able to answer the parts. The first part is probability of a two-digit number. So two-digit numbers begin from 10 to 90. So from 10 to 90, how many numbers will be there? Count. This will be 90 minus 10 plus 1. This is one way of doing it. Count the two-digit numbers, or from 90 take away the one-digit numbers. So one-digit numbers are from 1 to 9. 9 of single-digit numbers are there. From 90 remove that. So this will be 81. So the probability will be 81 out of 90. This is the first part. Let's take up the second part. Probability of a perfect square. So perfect squares are the numbers which are squares of your natural numbers, whose square root exists as a whole number. So we have 1 square, which is 1, 2 square, which is 4, so on. Let us see how many are present in this list from 1 to 90. How many are there? So we will have 1, 4, 9, 16, 25, so on up to 81. So we have starting from 1 square to 9 square. So how many numbers are there? 9. So the probability will be 9 upon 90. Third part, probability of number divisible by 5. So numbers divisible by 5 means the multiples of 5. So the numbers which are divisible by 5 are 5, 10, 15, so on up to 85 and 90. So how many are these? This is the first multiple and this is the 18th multiple. If you just count 15, 5, the table of 5, this is 5, ones are 5. So this is 5 into 2, second value, 5 into 3, the third value, 5 into 4 will be 20. Going on, this will be 5 into 18. So there are 18 numbers which are divisible by 5 out of total 90.